Hello everyone, my name is Praveen. Today I'm going to present this video as part of my final project for data visualization course in University of North Texas. So I have total 4 parts in my final project and I'm going to explain each part one by one. So first part is the multivariate data visualization using graphs. So we have several graphs to describe this multivariate data visualization. We can have a chord diagram, we have pixel representation, we have scatter plot matrix, we have parallel coordinates. And uh, for this part, we can have any diagram or we can have any graph to visualize this first part. So for the first part, I was to create a data set of my own uh, about relations between the people. So uh, it may be include the relation between the student and the person, the strength, length, and other factors. So as this is a multivariate data, I need to have 4 variables minimum. So I created a uh, own data set called as Spotpan. So I have a total of 6 columns in this data set. So the first column represent my name, student, and the second column represent person to whom I have relation with. So I have 15 persons with whom I have relation, and the relationship is column defines what's the relation type name of with that person. So I have some friends relation and work correlation and family relation. And then I have length of the relationship that determines in years. So it defines the how many years I have been in relation with them. And then the strength of the relationship. I have kept this for around 5. So the top value is 5. So I have given the relationship for each of the one. And similarly, the last column is similarity. So similarity is like a similarity of behavior between that person and me. So I have given these values for that. So if we let's go and explain in the graph. So to visualize this multivariate graphs, I have used Tableau. So I have visualized this data set in 2 different types. So first I have used parallel coordinates in Tableau, and then I have used chord diagram in Power BI. So let us explain. Let me explain first about parallel coordinates. So if we go to parallel coordinates in Tableau, we can just import the data, and then we can have the measure values and measure names. So first we will tag the measure names to the columns and measure values to the rows. If we can observe the data, we have numerical values with different ranges. So the length is it was in 20, 25 like that, and the strength is up to 5 only, and similarity is also up to value 5. So I want to have all these values in a single value. I mean, in a uh, all the values in the same range. So uh, I have created a formula for that. So before that, first we need to drag the measure names to columns and measure values to the rows. So when I drag these measure values, I will not have these values. Later, I will create these values by creating duplicate, or we can also create a calculated field. Why I was creating all these values is uh, to have these all the values in the same range. So for that purpose, uh, I have created this one. So this is the formula where we are comparing the total values to the minimum value and dividing it with a range of values. That means subtracting maximum value with the minimum value. So by this, we can get the values between 0 to 1. So I'm going to do for every value. For the same form, I have put the same one of every values, and I have the values between 0 to 1. So after completing this, I again drag those measure values to the rows, and then I have I have created dual access so that I can visible these parallel coordinates. So after creating this dual axis, I want to compute these measure values using the person, because I was calculating how a person is rated with the student. So I want to compute this one using the person. Later, uh, uh, as we want to define each and every person, we have a relationship like family, friend, and worker. So I have given relationship as a color. So it will differentiate the persons with the family, friend, and workers. So if we can observe this axis, we have different lines from different points. So these points tells about the name of the persons or the variables. So the variables here is the name of the persons. So we have different variables. So the highest, we can see there is a value here at the point 1, and we have different values. So if we can observe the data set, I have the highest value in the length of relationship for the uh, Sam. So is the family member. So if I go to parallel coordinates, you can see the highest value is for the Sam, and this is the top line, because for the length I have the highest value for Sam, and this for similarity I have the highest value for the same person, and for the strength also I have the highest value for the same person. So I have 25, 5, 5. So it displays every value on the top of the coordinates. And then if you can see some other lines are less than that, because if you can see the person is Persian, the length of relationship is 20, but not 25. That is not the highest value. So it was less than this value. And strength also, you can see like 4 and 4, but not the 5 value 5. So if the strength and similarity values are 5, then you can have the point here on here. So this is how the parallel coordinates works. You can easily hover here any part, any line, and we can find the relation of the person and the other values that have. I also described these in using the chord diagram. This is how I created chord diagram. But basically, we will not have any chord diagram in Power BI. So for that, we want to go to get this option and get more visuals, and we have the all the options, other options we have here, and we can find search for the chord diagram here, and just press the hat, and it will add it to the columns visualization headers. And then we want to select this chord diagram, and now I want to select various fields to represent these values. In chord diagram, if we keep the two value, I mean, if you keep a two value, then you can have only one value can be placed in this values field. So instead of keeping the two value, I will have only one person as a student. I have only one person as student, so I don't need to have them in the two value. So that's why I have given null to the two value, and I have selected them as person, and I want to get a value. So strength, length, and symmetry as the values. So by default, these are calculated and these are identified by the Power BI as the measures, and they are calculated as the sum. So when we drag those values to the two values, we will have like this. So what's Chord diagram? Like these values, uh, these act value represent the size. You can see like this is the length of relationship. It is calculating sum. So as we have higher values for the uh, length of relationship, it will give the chord width as the high value. So we have a high width value for the chord length, and then this is the similarity. You can see here similarity, and this is the strength. And these are all the persons. These are all the persons. So how you will define how you will differentiate each relationship here is if we select this value sham, you can click here and find you can see this is you will have three values going from the each other. One is for the length, and one is for the similarity, and then one is for the strength. So in chord diagram, the thickness and length describes the strength of the relation. I mean, so for the length of relationship, we have 25 for the same. So this is the highest value in this length. So it will have a highest thickness. You can see, and when you hover it here, you can find the length. So length 25, and if you hover it on the here on the this arc which goes to the strength, it will go, show you the strength of relationship, and if you hover it on the other arc, it will show you the length similarity. Sorry, yeah. So each arc defines the values, and the thickness describes the uh, greater or lesser value. I mean, so if you identify this data set for the Kevin or the person Kevin, the length of relationship is 6 and strength is 2 and similarity is 2. That means there is a less relationship with this person for the student. So if you observe that value here, where's Kevin? Yeah, this is Kevin. And if you observe this value, the thickness is very little compared to the share. It was very high and it was very little because the length is very less. Like Kevin length of relationship is 6, so the thickness is lesser. And similarly, we'll have other two works for similarity and strength. This is how you define chord diagram. And we can have filters also in chord diagram. So for that, we just need to press here, press the three dots here, and then we can add this one to the visual level filters. When we add this to the visual level filters, it will define you all the relationship values. So you can see there is three relationship, there is family, friend, and worker, and we have the count of each relation along a side. So if I select any value from this, like if I select the family value, it will show the only persons which are on the family relationship. So if I identify this among this, the thickness is high for Sham, Krishna, and Vijaya. So as the three members have the length of relationship is 25, so the thickness is high. And similarly, if you observe for the Naren, the thickness of this arc is somewhat less because the length is only 20. And you can select multiple things. So it will show you the family and friends only. And finally, you can select all the three values. So by this, we can filter the relation persons according to relation. We can also filter according to other level filters. I mean, other values like length of relationship. We can just okay. Okay. For that, to filter this value, we can add this one to the visual level filters, and then we can find out that. See, you will have filter type as advanced filtering. Instead of advanced filtering, if you keep the basic filtering, it will show you all the values of length, and we can select anything like we have only 3 members with a length of fellowship as 25. So if you select that, we will get the 3 members like that. We can apply the filters. We can apply filters for every value present in here. So this is how we describe the multivariate data in Tableau and Power BI using Tableau and Power BI using the parallel coordinates and chord diagrams. So let's go to the second part. In the second part, I want to export the large data set with the Tableau. So I have the crime data set, which is about 1.3 GB, and it has 6 million records at all. So Tableau has the capacity to handle large data sets. So if you go to the part 2, we'll have a data source. So when we connect Tableau with those data source, we will get an option here asking for update. So when we press an update, it will show you all the columns. So if you observe the data set here, we have ID, case number, date, log, and so on. So here from the question they asked you to explore about FBA codes, primary type of crime, and then period of data that has been collected, the trend. So let's go to the data. If you can see, we have a case number here and primary type and also FBA code. And these are the main values that we will use here. So in Tableau, by default, I mean, it will recognize the dimension values and measure values based on the values inside it. So if you see here case number, it will be recognized as a dimension. Why? Because it was not a quantitative data, because it does not have only numeric data. It also have alphabetical also. So by default, this case number will be recognized as dimension. So we will change this dimension to the measure, so that we will get the how many number of cases that was not recorded for each type of crime. So if you go to the exploration, so first we will explore how many FBA codes are there and the count of the cases for each FBA code. So for that purpose, initially I have this case number here in the measure names because it was declared dimension, and I dropped that one to the measure values. So it was taken by default as a count of distinct. So if you can observe, I have dragged this FBA code as into rows and the case number to the columns. Later, I have developed this graph using this bar chart. You can see horizontal bars. Then I have given the labels. So we can easily identify that the FBA code 06 have highest number of cases, that is around 1 million cases. So like that, for each cases we have different values. So the highest is 06 and the least code is 01B, and it has 22 number of cases. Later we will find the number of cases for each primary type. So we have different primary types of crimes. So we will observe that. So this is all the primary types of cases in the in here primary type, and I have sorted this according to the value of this. So you can see I feel as case number. I have sorted this in the case number order, count of case number. So the highest is 1211078, and for the theft. So there are about 1.2 million theft cases, and other records like the second highest is battery cases, and if you have the least one is domestic violence, and it has only one case. So now, as they asked, I have defined what are the FBI cores, primary types, and total number of cases for FBI and primary type. And finally, I will combine both these FBA cores and primary types into one sheet so that we can identify what are the more insights in this dataset. After combining these, I have observed an interesting point like for each FBI code, we can have different number of cases, different number of primary types. If you can see 08B, it have three type of crimes, and for those three type of crimes we have the single FBA code 08B. So similarly we have for 26 we have these number of primary types. So after adding this, I also observed another thing, which is you can see battery. I can simply show you from here. So if you observe this battery case, it was in 08B FPA code and also in the 04B FPA code. So from this we can get to know that the same primary type of crime can be in different FBA codes. So later I have sorted in the order of count of case numbers, and after this I have come to know that theft in 06 FBA code has highest cases with 1.2 million, and later after that we have battery cases in 08B FBA code with 916476 number of cases. And similarly, the least one is homicide in 01B, because we have two different homicide primary types in different FBA codes. So I will show. So you can see the homicide is present in two different FBA codes, 01A and 01B. And in 01B, it have 22, and in 01A, it have 6,925. So after combining these FBA code and primary type in the rows, I get to know that same type of crime can be in different FBA codes. So this is how we explain about the count of each case, count of cases for each primary type and FBA code. And later I was asked to find the period of the data that has been collected and trend of the committing crime. So for that purpose, I have dragged upon the year. Actually, we can drag a date also, like from the date. So we can have a hierarchy if we have drop the date and the quarters, the months, the day. So this is how the trend goes on. So I have given the case numbers as count of case numbers in the rows and data as in the columns, and then I have labeled as according to the case numbers, count of case numbers. So after observing trend, I can identify that in the year 2001, it starts from year 2001, this data set, and it have 485669 cases in this 2001 year, and later it was increased and it was gone to 486683, and from then it was started decreasing. I mean, for every year the count of cases is decreasing year by year. So this is how the trend goes on, and in the 2015, sorry, in the 2015 year, it was dropped very randomly. Like in the 2014, it had 273. above 250K, and in the 2015 it have only 151K. So that means between 2014 and 2015, the count is decreases, right? Uh, the count decreases, and if you can observe, I have given a trend line, and we can I find that trend line by going to analytics and dropping that trend line. So the data set, I mean, this data have followed the trend at 3 times, like in 2004, 2004 and 2005 and 2014. According to trend, it follows, and in the remaining years, it was gone up and down. And the average number of cases is around 390K. This is how the trend goes on. So the next part is data visualization with Tableau. So I have the sales records one CSV data set, and I need to identify the sales and profit of each category in each region. So I have here two different types of variables, and I want to compare each and every two variables, I mean sales and profit. So it is better to use scatter plot matrix for this. So for this part, I have used scatter plot matrix. I have connected to the data set in the Tableau and have get all these columns. So first, why is scatter plot? Scatter plot matrix is best used when we want to compare two values or multiple variables with other values. Like so, I have sales in the y-axis and profit in the x-axis, and the values are being set in twist coordinates according to the individual values. So, if you can identify here, the sales is 163K and the profit is minus 2000. So it will identify according to the coordinates and place the values in the in the graph. So I have given region as labels and then category as colors to differentiate each category, as they have asked for the each from each category in each region. So when we want to compare two variables, scatter plot matrix is the best one to visualize. And if you have the all those values in a single line, I mean around us, if you can see here, these values forms a straight line. Okay, central value is not that much straight, but remaining three values is around straight line. So that means they have the more correlation. So the more straight line it forms, it will have more correlation. So for the best fit model, the p-value should be less than 0.05. Okay. Now if you observe this data set, I've given the region, category, sums and profits. I've given sum of sales as rows and sum of profit as columns. And we have a category, furniture, office supplies and technology. So we have differentiated using the category types. And if you observe this graph, in the three different types of categories, in the west region, it have more sales and profits. You can see the sales here is high in with around 252,000, and in the technology category it has 251,000. In the office supplies category it has 220,000, and for each category west region have the highest sales and profit. So as x-axis define the profit, you can see this value has the highest profit among every category in every region. So office supplies category in west region have highest profit with 52,000, and the least profit is for the central region furniture category, and actually it was went into losses as minus defines losses. we can have profit as minus 287. That means it has gone into losses with $2,000. So for each category, the highest sales and profit is for West region, and the next one is for the East region. You can see after West, we have East, and for the technology category, the highest one is only East, and for same for office supplies, we have the second highest as East. And if you can identify the similarly, if you can identify the South region has the least sales and profit for each category. So for furniture category, we have less sales in South region, and for also office supplies, we have less sales in South region. And similarly for technology, also we have less sales in South region. So only profit is less in Central region for the furniture category. Otherwise, the profit is less for the profit is less for Central region in each categories, like furniture category, office supplies, and then for technology category, the profit is less in South region. Okay, so this is about the first question, comparing sales and profit with regions. So you can easily identify here, like but creating this scatter plot matrix, we can identify the relation between sales and profit easily by plotting each values as a variables like this. And then we have another part that asks for sales and profit for each segment in each region for each category. So here segment will also added. So if I identify this one, I have this scatter plot matrix with the sales as a y-axis and profit as a x-axis, and I have differentiated each one using the category and differentiated the segment as shapes. I have consumer as circle, corporate as square, and home office as some plus sign, and then regions as sizes. So the central region has very small size, and west region will have very large size. So from this, if you identify the highest sales is for west, because the larger circle, you can see the larger shape is for the west region, and then if you can identify the circle shape is high, that means the consumer. So the consumer segment in each category have highest sales and profit, and you can identify the sales and profit for each one, like profit is of 4,000 and sales of around 120,000 for the furniture category in west region, and this is the highest sales and profit for any category in any region in any segment. So technology category in west region for the consumer segment have get the profit of 27,000, and it have sales about 132,000. And similarly, you can identify the least one. This least sales is for home office segment with south region in furniture category with 16,853 sales only. But the profit is high in, sorry, the profit is least in furniture category, and it went to 3,994 losses. But the sales here have a high number, like 86,229 compared to all these values. We have also another value in home office segment with in furniture category with that goes into the losses. So the furniture category, as we know that furniture category here went into the losses. So that's what we have found it here also. So furniture category, these both of furniture category in central region only, but with different type of segments. So using this scatter plot matrix, we have identified sales and profit. We compared sales and profit and find a relation between them. When the sales is high, when the sale and profit is high in for this category, and the profit is less in this category, even though sales are higher. Like that, we have compared the relation and also used segment, I mean, differentiated for each segment, category, and region. And this is how the trend goes on for each one. And if you observe trend, the technology category have the best correlation, as they have the p-value for this one is 0.0007. That means it has very correlation. The correlation for the technology category is high. So this is how we can find the relation between variables in using scatter plot. We can also define these values using some other graphs. Like we have all these graphs. I mean, we can represent these values in bar chart, in circle views, in tree maps, in box plots, and we can identify these values in these charts also. But the scatter plot is very easy to understand, and I've tried to explain this in bar graphs, and this is how it will look. And I will go to the presentation view. So if you can see, the profit and sales are differentiated by colors. So profit is blue and sales is orange, and we have a segment: consumer, corporate, home office, and we have several regions for in this, and the type of categories. So we can easily identify, like say, which sales is greater, profit is greater, or which categories are higher sales in this region. You can easily identify that one. But when we have these many number of categories in different segments and different regions, it is very clumsy and difficult to identify the sales and profit relation here. So if we can identify here, the profit goes to the minus value for this, as similar to in the scatter plot matrix that I have shown earlier. But you cannot easily describe the relation between sales and profit using bar graphs. So to identify the relation and how a value, how if a value changes and the value changes, those relations can be identified easily by using scatter plot. And the final part I have is part 4. And in this part 4, I have done data visualization using Python, Pandas, and Matplot library. So for this, I have a data set called as Pyma database, and it has this number of columns. It has column names as this one, and the explanation of each column, number of times pregnant, and plasma glucose values, and the skin type, skin thickness of skin in millimeters, test as for 2 hours, 6 dimension and test, and different age column, and finally the class. So it is actually the issue when we need to predict the values. These are all the values using which we will predict the class. So in this part, we will not predict anything, but we just identify how each columns and each columns are affecting the class value or the relation between each columns. So I use the Pandas library and Matplot library for this visualization purpose. And I have downloaded a data set, and that data set will not have any columns. If you can identify here, it was started with values, and it does not have any columns. So I need to create the columns. So for that, first I have created and I first I imported the libraries and given the names for them. And as I told, I don't have any column names. So I have created the column names in a list called as names, and I get those lists from here. Okay, and we can see the file name where I have stored this is the location where this PyMa data set is stored, and then I have taken this data set into a data frame using by reading the Excel sheet, the CSV data file using read CSV method in Pandas library, and I have given two parameters for that. The first name is file name, that means the location of the file, and the second name is the column names. Column names defines the list. As I don't have any column names, I am defining the list of the column names. And then I was checking whether there is a null values or not. So if there is null values, just I will drop them, and then I will represent the top 5 values. So you can see the column name with values in the data frame. So later I need to develop, I need to visualize in I need to visualize in uni-variate data visualization in 3 forms, that is histogram, density plot, and box plot, and the multivariate using scatter plot. So for that purpose, first I have displayed using histogram. If you can see, I have given DF as data frame, and I have a method in data frame called as histogram hist, and I have given the parameters figure size. Figure size represent the size of the each figure. So 12 as rows, I mean x-axis, and 8 as y-axis, and I'm representing this one using the plot matplot here. So if you can observe, these are the columns. So I have 8 columns, sorry, 9 columns, and 8 columns representing each value, and based on those 8 columns I have one column class variable which defines the class. So if you can identify, I have only two values, 1 and 0 in the class. Okay, I will show you in the this one. So I have 1 and 0 in the class. So those are identified by like this. So 0 value has 500 0 values, and about 200 to in the middle of 200 to 300 I have one value as the class. So this is the count, and this is the values. So for in the age I have around 300 members with the age from 0 to 20, like that. From 20 to 40 I have this number of people, and for 40 to 60, 60 to 80, and similarly, like if you can observe this class, I don't have any values here. That means there is no values that defines these values. I mean, between those values, I don't have any value in the data set. So I have defined univariate visualization. That is, for each column, I have defined the visualization, how the values are changing, how many number of values are there. So for each column, I have represented histograms. And later I have density plot. For density plot, I have given DF as data frame and plot of the name. Kind defines the name of the plot. So I have given density as the name, kind, and layout. Layout defines how many number of values should be present in each row or each column. So I have given 3 by 3. That means I need to have 3 rows, 3 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 rows, 3 columns. And then legend equal to that defines the value. So if the legend is false, it will not show you this value, this press that, but those values we cannot show. So I have given true as legend, and the font size differentiates defines this font size and the figure size 12 by 60. And finally I have represented using Matplot library. And so I have found the values, and if you can observe easily by class, yeah. So I have only 2 values, 1 and 0. So the 0 value is highest I have. So this different 0 values, and this are represent 1 value. And similarly, I have the box plot also as invariant visualization. the same method I have given, but the kind as box and layout 3 by 3, figure size 12 by 16. So it will define you uni-variate visualization for each column. Sorry, yeah, for each column, and we can find the column names here, like plus, and we have two values, 0 and 1 in the class. So that's why the box plot is like this with a 1 value and 0 value. So we have more values in 0, so it was shown as green. And yeah. And finally, we want to represent multivariate visualization using scatter plot. So multivariate visualization means it defines the relation between the multiple variables. So you can see uh, scatter matrix, and I have defined this scatter matrix from the Pandas library. So I input a scatter matrix, and in this scatter matrix, I want to add the data frame to which I need to represent the scatter matrix, and then I need to get a figure size and alpha value, and I finally showed using Matplot library, and I found this one. So this defines the relation. That means this is the peg value, and this is how other values are related with this peg value. And for the plus, this is how the other values are related. That means this shows how the other values are related for this column. So if you can observe the class value, it has 0 and 1 values on. So this is actually the histogram value that we have found out here. So this is the histogram visualization, and the remaining of the how the value changes for each value. This is the distribution of value, other column values for this column values. So using this, we can identify the relation between different columns. So if you can observe this value like plus, we have highest distribution for these columns. That means they are more correlated like that. So I have represented multivariate and univariate visualization using pandas. And from this part, I'm concluding the project. And so that's it. Thank you.